The transition from Ricard's presentation to the first of the two about the project, I want to actually I was going to put this in the slideshow, but I thought I would just go straight to the source. So these are questions about intercropping, reducing inputs, while still maintaining food security, biodiversity. These are things that are on the EU's radar, and they understand that there aren't easy answers quite yet. So over the next year, myself and about 30 other experts from around Europe are working with the Commission to focus on ways in which we can reduce the barriers for using some of these ideas, as well as identify places where the whole industry needs to start to focus. So this mechanization question is not just me and Ricard, big farmer, market gardener, having differences of opinion. These are real questions that people are trying to work on. And if you are capable of reading and listening to me at the same time, which I hope that many of you are, because that's how I usually do my presentations, is that you read what I put there, and then I just sort of talk to the audience. You'll notice that this idea about increasing farm resilience, efficient natural resource use, reducing dependency on external inputs, all of this is almost identical to what we're doing with the Lill-Nägels Agroforestry project. So it's a really nice thing to see that we were one step ahead of the announcement for this group, but this is on the radar. And I don't just put this up here. Everyone says, and I say it myself, I'm a little bit crazy. I'm willing to do that because what I'm putting at risk is a pilot project or a small farm or, a few beds to try new things. I understand it's difficult for larger farmers to do, to take on new risks. But, it's not just me. You heard from Joel. He synthesized a lot of great literature and farmer experience from, around the world together. So these are things that are coming, and it's events like these where we get to see each other and I'm really glad, I thought there's a camera here for some reason. There's a camera over there. The folks online, it's really important that you're here too and asking questions and interacting because, 60, I was so surprised to have 60 some people decide that they would like to attend at least part of today's seminar, especially on such short notice. So, people are working on this, and let's show what we're trying to do if it's decided it actually wants to load. Cool. All right, is everybody seeing this online now as well? Does anyone online want to say yes, no, maybe so?
Yeah.
Yeah?
We are seeing it.
All right, cool. All right. Okay, so the first session is going to be lessons from our inaugural year. And then the next one, we're going to look at the future of that project and also, maybe some important points for temperate climate successional agroforestry more in general. So when we get to the question and answer session for today, please try to keep the questions to the session so that if you're okay, maybe he's going to cover that in the next scenario. If it's about someplace other than Lill-Nägels, please, hold it for the next one. I tried to keep this one as short as I could, but you'll find out at the end that I couldn't. I only have 2 topics for this next hour. The first one is supposed to introduce you to the project, because I understand not everyone joining has any idea what it is we're actually doing. And then some of those inaugural lessons. And we're going to look a little bit at tractors to soil. And as you can see here, we've got a little bit of soil and quite the big tractor. So just some views of the site to get started with. I have practiced this one a lot more than the second session because it's a lot harder to talk about what you've done than what you plan to do. And I'm going to have to go rather quickly, I think, through this. So let's see how it goes. What is the Lill-Nägels Agroforestry project? Well, we didn't make it very easy on ourselves because we're using jargon. Successional silvo-arable pilot project. So successional silvo-arable system, you're thinking, well, this doesn't mean anything. Successional, we talked about that, or Joel talked about that this morning when he had those, early young soils, juvenile soils, mature soils, this process in the most simple terms of organisms affecting change on their environment. That change creates new niches, new places in space and time for new organisms to move in. And the classic idea is that it would go from a bare field to a forest in this kind of climate. Although, a nice paper just came out saying, aha, actually there were lots of open woodlands in Europe quite a long time ago. So we have a diversity of landscapes, but in general, moving from more simple systems to more complex systems that have a lot of embodied sort of energy and lots of relationships taking place. And a silvo-arable system is very straightforward. That's just simply integrating trees or shrubs into arable cropping. So not pasture. All right, so that's all that means. Pilot project means we're trying new things, and that's why it's interesting. We wouldn't be doing this pilot project if we had answers. If we had the answers, I'd probably be at home. To be honest with you, we wouldn't need to ask for development money because we would just go ahead and do it. So a lot of what you'll see today are things that we're not sure of, and that's why it's interesting to try. And we have project objectives. I'm not going to read these for you. There are 4 main objectives. And the reason why these 4 are here with numbers is that they're sequential. That means we're not starting this project with implementing novel systems to attract new talent to agriculture. 4, 3, and 2 are products of the initial starting conditions. The initial starting condition is we want to see how we can bioremediate degraded agricultural soil. That's the thing that motivates me to do this project. If we reorder the objectives, it's not like they aren't important, then the way that we would have executed this project would be completely different. So when I talk about bioremediating degraded agricultural soil, think back to Joel's 3-legged stool there. Okay, so we are focusing most of our attention in this project on the biological part of the stool to see how, if we minimize our interference in the physical and chemical properties of the soil, just how far and fast can the biology do things. Because as soon as we start to add anything to the soil, be it fertilizer or limestone, we have completely altered those conditions. And then there'll always be the question, well, what was the biology doing? What was the biology doing? Are you sure it was the biology that was making those changes, or was it all these other things that you added in based on normal things? So this project really is focused on that. And then building from there, we say, okay, if we bioremediate our soil, how should we do that? We should mimic local ecosystems. Agroforestry enters the equation. Agroforestry has problems. You wait a long time to get any revenue. Successional agroforestry steps in to help answer that question. If these things work, then how are we going to sell any of this stuff? Right? So the project is built on one on top of the other. And that's how I've seen it. That's how we talked about it. So it would be very different. Because also, if you think about it, if you read these 4 already, these first 2 are very rare. There's very few people really doing this on a farm scale with this almost total emphasis on the biological aspect. It's extremely rare. You'll find a lot of new talent coming to agriculture these days because of regenerative agriculture. You'll find a lot of people direct marketing crops. This isn't really, it's still rare in the grand scheme, so to speak, but it's not uncommon. Whereas these first 2 are very uncommon, and that's why they're interesting. So here we just have some interesting photographs of the site from around the year. And I do want to also thank Florentine. He was our assistant for 10 weeks this summer. And without him, we couldn't have turned some things around and get the project to where it is today. At the end, I will remember to take time to thank our sponsors, because the people who made this project possible. So at the end, I'll also get to them. But now it feels a little bit clunky putting them after Florentine. So Successional Agroforestry, we have hammered home the ecological underpinnings, but you can also take that a different way. You can also think about it economically. So going from cash crop to cash crop. So if you were thinking about agroforestry, not running an orchard, so an orchard is it's trees and agriculture, but it's a slightly different thing than a silvo-arable system. You've got a lot closer rows. You're definitely focused on one thing. This is a little bit different. So if you're applying apples and pears to a field in which you're growing cereals and legumes and oilseed radishes, in a silvo-arable system, you're probably going to be going for non-precocious, rootstocks and cultivars. You're probably going to be using larger species because they invest in the infrastructure to keep a dwarfing tree alive in the middle of your, wheat field. The numbers don't add up until you start to cram all of that into a specialized system. So you're going to be waiting a long time to start getting your first yields. Obviously, you can affect that with the cultivar selection and all these other things, but the point is you have to wait a long time. And as you wait a long time, then this gap turns into a big problem because of the revenue. There's no money coming in, but there's all this money going out. And as that money that's going out starts to add up, the pressure on those apples or pears in this scenario to perform when it's their turn to come on the stage is pretty high, because all you see is this big dip in your budget about all that you've invested in these trees sitting there in your field. So how do we address that? Successional agroforestry steps into play because you can step back from your longer term species and come all the way back into the first year to generate revenue. Now, this is not, this is not a business plan, this is a schematic. It's just trying to demonstrate that you start generating revenue and you start backfilling those expenses. The point isn't that garlic or rhubarb or even cut flowers are going to actually pay for the whole system. I mean, if things go really well and you design it really well, it might, but you're reducing the pressure on the final species that, of course, some of these are going to overlap with, especially in our model, because it's a stratified system. We don't have just a singular level of plant. So it's just an example to demonstrate how you can backfill and use that space, generating some revenue. And also, as you pay attention to doing good cultural practices of your early crops, you're improving those conditions for the final species. So you're actively improving the whole thing, and your management is also able to identify then issues that are taking place in the agroforestry system. So it's a really interesting model, but it's one that really isn't practiced very much at all in cold climates. You see aspects of this with cultivating cover crops underneath the trees or something like this, but there's no revenue attached. And we all know the issue of wildlife. So, if you want to graze your cover crop to produce a little bit of revenue from that right next to your trees, the sheep and the goats or the cows, they're going to reach over and grab parts of those branches. So it's not really feasible necessarily to do that method. So it's useful, it's integrated ecological succession to some degree, but not economic succession. Also, pay attention to the strata. So the idea is that, generally speaking, in this system, we're going to try to pair crops which are one strata apart. So we don't want to put apples and black elderberries next to each other, because although you can, on paper, sort them into apples in the canopy, and then your black elder is a little bit smaller, they're really similar. So you want to skip a strata and move down, because rhubarb isn't going to interfere with an apple tree on a semi-dwarfing or a full-size rootstock with some decent planting. So keep in mind that we're not trying to also make it out that you're going to get 100% yield from all of these. All right, so it's not like I'm saying you're going to get all of these, 1 plus 1 plus 1, but we'll introduce, if I put it in here, a different concept about adding up and how you can compare these intercrops to monocultures. So where are we applying these ideas? Well, we've covered that. We're in Kirkkonummi. This is mostly for some folks who are visiting from outside of Finland. We do have some people joining from elsewhere in Europe. It is 60 degrees north, 24 degrees east, so we prepare for minus 25 Celsius in the winter. That automatically removes quite a large number of species that we can play with. And then in the summers, we're also not that warm, so that also reduces the species. So some of what you're going to see here is, because it's context dependent, the site itself is 8,000 square meters. A new orthographic image just came out and I measured it, and I think we're at like 7,884 square meters inside the fence, but it's close enough. The soils are, everyone here knows this, but if you're online, glacial, right? So we have, in every field, usually, you're going to have a kind of a mixture of different soil types, because the glaciers really mix stuff up as they retreated and Finland rose up out of the sea. But that said, we still have like mostly clay loam. All right, you could get technical about what kind of clay loam, but that's a different kind of discussion. And these two images are just included for a bit of context. So I first visited a site 2021, the end of the growing season, and we can see pretty clearly, especially on the bottom, a darker patch of green and then a lot more lighter brown. This is what I'm talking about, that glacial distribution of the soil. Where the brown is, it's much more shallow. We have a sand loam, and there's a lot of bedrock rising up. So very different soil conditions in the same field, very common in Finland. And then also from drought conditions or drought-prone conditions here where those brown patches are to the field margins. You see these dark green patches. So because of the topography and the clay loam, you have all this water being shed from the sandy loam into the clay loam, and then it kind of gets stuck and it's got nowhere to go as it's trying to leave through the watershed. So these are the kind of considerations you have to put into place if you're going to do agroforestry. And you can get a lot more into detail. We've done a fair bit of detailed planning, but I didn't try to turn this into a permaculture forest garden where every single cultivar is specifically for that spot. We're trying to mimic a larger scale system where that kind of diversity, without robots powered by AI, we're going to be in trouble trying to manage that. Here's some plan views of the site. If you're unfamiliar with agroforestry, you're going to see this at least once or twice over the next 2 hours, just to keep it in mind. You have 3 main areas inside the field of the site. Number 1, you've got your margin or your headland. Number 2, you've got your tree lines. It's agroforestry, not agroforestry without trees. What do you call the space between the trees? Silvo-arable systems in English are called alleys. We're not going to talk about word choice, but it's not a very good one, but that's what it's called. And then you can see how we've taken that basic pattern, turned it sideways in our field, and dumped in a whole bunch of diversity. So the diversity is really coming from the biological elements themselves and not necessarily the physical space. This is very simple, very rigid spacing. We used GPS guided tractor to set all this up, and then lots of checking and rechecking to make sure everything was being planted in the right spot. So we didn't have GPS to put each tree. But the complexity is contained within a system that makes sense for mechanized work. The reason why it's this orientation is that tractors are annoying to turn when you're pulling an implement behind it. So if we had it pure north-south, you would be doing this all day long, and then you'd also really need to narrow the length of your tree lines, because the more you need to turn, the more annoying it is to have to slow down and be careful not to bump into a tree or a fence. So we've tried to cram in a whole lot of novel information generating systems into this field because it's a pilot project. If it's a real farm, a working farm, and this is meant to be a business from day one and not a development project, we would have a lot more space for moving the tractors. It's still doable, but it's one of these small sacrifices we're willing to make as a pilot project. And those alleys, as I was calling them before, we won't talk about them so much in this presentation. They'll have their own bit in the next one, so I'll just get rid of it, get them out of the way now. They're 12 meters across. So they're 12 meters across. It's the widest working width implement you commonly use, and then it also needs to make sense for the smaller implements you use. So 12 meter wide sprayer for applying those biostimulants, biofertilizers that Joel was talking about, fits in perfectly. And then you have 3, 3, 3, 3 is 12. So then we can introduce strip cropping. And also, even if you weren't doing strip cropping, that your machines are still going to fit without wasted space. So that's the alleys for now. We'll talk about them a little bit later. If you turn it on its side and start looking at the design and the complexity, don't try to read. I would advise you to look for colors and see if you notice if there's a regular pattern. Again, it's not a permaculture kind of home garden. This is supposed to be a larger scale system where the components are replicated over and over again, so we generate enough data about how do the cherries, plums, and pears and currants actually function. If I had one of everything and that one dies, then it stops producing information. So here we have a little bit of redundancy, we have cross-pollination, and as you can see, it's certainly not an orchard. 51 fruit trees is not an orchard, even if they are on larger rootstock. It's not an orchard, and it's not meant to be an orchard. So that is, I know it's a criticism of agroforestry projects sometimes, is that it's, jack of all trades, master of none. What's the point? Well, it's the stacking and the functionality that you get when you stratify the system, or we think that you get when you stratify the system, that we think it's going to work. All this is accessible on the website with full details on why it's planned that way. Everything is more, if it's not there, it's coming after Monday when I have my final meeting. But as you can see, that's what we've got going, and yeah, we do have grapes. So I'm really excited about having some grapes. And Ricard is smiling. So is everyone else. And then you've got the garlic there too. So it's not like inconsiderable either. 38 kilos, 2,800 cloves of garlic is a fair bit of garlic to put in. That's a small business all by itself. If you wanted a little bit of pocket change, you know, you could generate a few thousand euros of revenue a season by doing that and pay for a trip to Spain or something in November and December instead of being here listening to me. So, you know, it's big enough. So I'm trying to say it's big enough that if what we're doing starts to show promise, that you can't necessarily just wave it off. But of course, we can't also say that it's proving anything. So as a development project, we sit sort of here in the middle. And on one side, you have farmers. And you have farmers running farms for businesses. And they have certain tools and needs that they need to do and systems that work for them. And then you have universities that are doing field replicated trials. Again, jack of all trades, I wouldn't say master of none, because we are able to do things that neither universities or farmers are usually able to do. That's what the beauty of Novia and the kind of projects that we do here is that we get to do cool stuff like this. We don't have to do a replicated field trial. But what we're hoping is that farmers will take something neat. Okay, I'm lingering on this slide too long, I'm sorry. But take something interesting from this. And then also, if the information that we're gathering is interesting, then maybe a researcher who can design a project gets interested. So we're trying to send signals to the whole community with this project. Now, you know, there's a meme, you know, how it started, where it's going. I'm not too old, it's not an old meme now. Do you know these? Where people, what people think I do, what I actually do, what my neighbors think. Well, this is something that I presented in the winter before we had started, of the schematic of what it might look like early in the year. So what does it actually look like? So here, if you're standing at the head of the tree line looking down, you can see that the garlic is there, the trees are there. The only thing that's missing, this mess over here, is a diverse cover crop. Yeah, put some stuff in. We've got plastic. That's not a diverse cover crop, but that is an adaptive management decision because things don't go like Strömsö. So we had to do something to reduce the weed pressure, and occultation is there. And then of course we can always use this plastic elsewhere on the system, or well, otherwise on the farm if we scale it up, because the plastic doesn't degrade that quick. In the yellow, you can see that we have two 75 centimeter beds, and in the middle there's a 50 centimeter bed. But they're all stuck together, so you just have to know that they're there. So that means we have 2 meter wide tree line. In another context, I think I might even go wider. I might just make everything 3 instead of having 3 meter wide strips for the alley cropping, and then 2 meters. So then you get 3s and 2s, and it's just getting weird. But we could fit more trees in by making it smaller. The idea here is that we are using photosynthesis, biological plant communities, to change the soil's chemical, physical properties, to do all those objectives. To do that, those communities need access to topsoil. If you have narrow tree strips and you're cultivating the alleys, this has been cultivated, and you're ripping up their tree roots, you send the tree roots down. Everyone says, that's good. Well, it's probably pretty good. We're going to do the same thing. But if they have a narrow space, they won't develop a fine feeder root system in the topsoil where you're always going to have the best gas exchange and microbial activity. So we need a wider bed in order for them to do that. And if you build a wider bed, they will come with your weeds. So we want to deliberately then backfill those niches we created with species with that successional model in mind. So later in the summer, after garlic, this mess, again, it's hard to see, but this mess with some purple flowers, that is a diverse cover crop growing after garlic was taken out. So garlic is a great crop for us because it does finish early enough that we get those big, bulky American cover crops growing. It doesn't end in July, it's sort of just getting started. So you can start to channel solar energy into the ground immediately after harvest with garlic. So garlic is a really great crop for us for a lot of reasons, and it doesn't require a refrigerator. But one other reason I wanted this picture on here is that if the sun is shining from the direction the arrow is, and it is, we've got this cover crop on this side now, because there's a crop rotation, and then the trees, this is in October. This is late October, a rare sunny day, and the very last bit of photosynthesis possible is being captured as the sun is still setting, and it's hitting a stratified vegetative wall, so to speak, absorbing that sunlight. Maybe at this point not sharing so much to the soil, except for the annuals who don't know winter's coming. But we're grabbing every last drop of sunlight with this kind of system. We're deliberately filling the niches. And what does it look like from the side? Well, it's really, unless someone's going to carry a big whiteboard and put it behind your tree, it's hard to get a good picture. But we can see here that the cash crops are labeled in green. This was taken before the currants were put in. But we have an apple and then 2 rhubarbs. And look, the rhubarb is not the same color because it's a dual use. So it's a cash crop, but it's also a biomass support species like these willows are. So they're early succession species adapted to poor soil conditions, wet soil conditions, willows are. Some species, I don't know if the 2 that we have here do fix nitrogen in their stems, but willows and poplars have been found to, sort of like that maize, have aerial rooting parts, not rooting parts, but aerial parts that have the symbiosis for getting nitrogen. So the willow really isn't, they can absorb excess nitrogen from the soil, but they don't necessarily have to. And since we're not adding nitrogen to the soil, they're going to have to be feeding, if they are, they got to feed those in there. So these are service plants for the apples. They're not meant to grow into a big willow farm. They're meant there to grow fast, rapidly, go up as an emergent strata, an emergent layer above everything else, and capture sunlight higher above the soil surface. A recent study, not in agriculture, but in temperate deciduous young forests in Germany, found that one of the most correlating things with total biomass production is how much sunlight is reaching the ground. It's like, well, kind of, yeah. It's like, thank you for quantifying that, but this is exactly what we're doing here, is that we're trying to capture every last bit of sunlight. Because if we don't choose something to go there, nature's going to fill that with something else. And even if we do fill it, then nature's going to try to put something else in there. We know that that's the way it is, but at least you're taking one step ahead of the game. And then probably one of the more controversial aspects of the project is the inclusion of non-productive forest species. So this is a baby oak tree that is growing from an acorn. So we planted almost 1,000 acorns, inoculated them with ectomycorrhizal fungi, and we're glad we did that because we had put in 10, 14 other species of shrubs and trees by seed. Some of them, like the maples, I was really excited about because they're a great biomass tree for us and they have a lot of other functions. They died. So we had a late frost and they died. But the oaks were, sending down a taproot, and then they came up a little bit later. Not every single one of them came up, but it takes about an hour to gather 1,000 oak trees, acorns. It's not, if you're never going to spend an hour to gather seeds for your agroforestry project, then maybe agroforestry just isn't for you. Or you buy them online. Like, you can just go anywhere and pick them up. But the idea here, and this is something that's not totally supported by, evidence yet, and actually that same study about total biomass production in deciduous forests was also looking at the effect of endo and ectomycorrhizal associating trees. They had a hypothesis that diversity in mycorrhizal associations would increase total biomass production. What they found in their study, which they admit, and they talk about the flaws to it, that they didn't find it. But the key here for me is that just because we don't know yet, I'm pretty sure that there's going to be some other benefits to having ectomycorrhizal fungi in the system. We just don't know about them yet. Perhaps I should have inoculated them with truffles. And then Ricard would be wondering how we're spending the project money. But you can buy hazelnuts and oaks inoculated with truffle. It's not it's a bit of a gamble, but they're in there. They're long-term biomass species. We're going to talk about the management a little bit later. Whew, there's a lot to talk about. So just some views of the site. So this is what we started with. This is putting up the fence in July. We got hit by a drought. 2022 July, it stopped raining as soon as I started the project, and it didn't start raining until September. So it was very dry. As you can see, now this is around my birthday, the end of September. the grass got cut once in June before putting up the fence to make it easier to see where everything was going to go and to do the work that needed to be done. One cut and it never regrew. That's how bad that drought was locally where we were in 2022. So if you're thinking photosynthesis, biodiverse plant communities, improving soil, there's not, we didn't move the needle at all. So it is a bit of, it's sad, but that's the way it was. And this is how it looked in 2023 in the spring. So this is probably June 14th that this was taken. This is the newest one. This is from they did the whole Helsinki area, they did the new photographs for. So I took this from the Kirkkonummi map service. And you can see it's nice and neat and everything. This is just before midsummer. So we also then got hit by another drought this year. So our project has been stumbling along in the dark, and that's why I don't have anything really to share about the alleys, because the tree lines we could only keep alive with about 1 liter of water per tree until the irrigation got up. So they had like 1 liter of water from mid-May until July.
But then we got the drip irrigation.
Then we got the drip irrigation, and then they were happy. So here, finally a thunderstorm is coming. Very happy about that. You drop to your knees, take a picture. The garlic died because it didn't have any water. We probably won't get into that too much. And even though it started to rain, it takes a long time to start to recover from drought. So still not much going on except in the tree lines. But then by the end of August, you can see so the blue dots, those are the flax that are blooming in these biodiverse plant communities. It really started to come along. Lots of bare ground still, but there was some progress. Let's look at some inaugural lessons. We're not pretending like we're in 1.5 years that we're going to have a lot to share. I mean, it's an agroforestry project, got hit by the drought, not much to be able to say. So I'm just going to focus on some things that for many of you are going to be, not all that exciting, but hopefully I'm speaking fast enough that we finish early enough that there's a question and answer. The point of this isn't to tell you everything about the project. The point is to hit enough points about the project that you say, oh, that was interesting, I want to ask him more about that. So let's look at this in lessons. Lesson number 1, extend your timeline, especially with weeds. Okay, so we had a lot of issue with weeds this year because, well, look at what we started with. This is a running grass, couch grass. I'm going to butcher it. Juolaveina. Yes, every gardener's favorite. It's 8,000 square meters of Juolaveina. All right, and then we're going to try to bring it back into an arable system and not graze it. But we've tackled it before. Kimo's eyes are raised because he worked with me at Local Lab 2 summers and he knows about dealing with it. So extend your timeline because here's some of that weed pressure that's coming up. And when you have a drought, we're not going to be able to get into how I was managing the weeds, but let's just say that dry compost doesn't really allow for effective mechanical cultivation if you're trying to maintain a mulch layer. If you want to hoe the stems of the grass, to death and mix it, that's fine. But if you want mulch, you're not going to do that. So we had some issues. So you should begin that occultation period or other weed suppression, glyphosate or other herbicides or deep mulch. There are all alternatives. At least 1 year prior to starting. I'm going to jump off from that in the next session when we talk about how this might scale and help farmers get into agroforestry systems. And then a final suggestion here is that, if you're going to have 2 meter wide tree lines, then extend it another meter on either side if you're dealing with something like this. I kind of wish I was dealing with an empty field, but at the same time, I'm not. So here we are. We're starting with this. And you can see how if you've never done occultation before, it's highly effective. So it's one way to go about it. There are other methods, but I would recommend this because then you can reuse the plastic elsewhere. It's plastic, but it does its job. So Chris, yeah, it's white side up because it was a drought and hot as all get out. So I wasn't trying to solarize my soil. I was trying to kill the weeds underneath. So I wasn't trying to sterilize anything. So the white side was to help reduce the temperature underneath. So you can see it's black and white. So you can choose whatever side you want and make a checkerboard even. So lesson number 2, mechanized tree bed preparation. That apple tree is there for, it's a prop. I just shoved it in the hole so I could take a picture of it. This is around May 1st, and this is our heavy clay loam soils. I was mostly doing this all by myself, and I'm not trying to say that well, you can see I'm not a very strong person. You should probably make that out from the back of the room. But we have soil bulk densities of about 1,200 kilos per cubic meter. That's measured from the near infrared. So that's a lot, but that's not a cubic meter. Okay, all right, but if you're doing, this is in centimeters, if you're removing this much soil per plant, then it's about 120 kilos of dry soil. I don't know about you, but that soil wasn't dry. So clay soil, wet, spring, needing to plant bare root trees. Oh boy, not the best thing. 150 holes is about 18,000 kilos of soil moved by hand, mostly by myself. Except for, there's a good portion of that Florentine definitely helped me with in the summer when it was a bit less wet, when we put the currants in. But this is a big problem. But again, this is a pilot project on 8,000 square meters with a certain size budget. There are machines, we're going to look at it in a second, that can handle this. But can you justify buying it for the project? So we've had to use existing resources and time to do what we can do when we can do it. So yeah, imagine if it's wet. So clearly wider scale adoption requires mechanization. Fortunately, not just myself, but people who are real experts on this have already thought about this. Here is a co-developed tool, it's a combi tool from Ernst Goetsch and Tech. So I don't speak German, but this is the name of the company here. So Ernst Goetsch is the popularizer. There's probably some other people he's talking to. Syntropic agriculture in Brazil. He's a Swiss geneticist who moved to South America and then eventually to Brazil and has been farming ever since. And he also understands that, yeah, you really don't need to be doing everything by hand. So what this is a subsoiler and a tilther in one, so you can make your bed prep in one go. It's only 80 centimeters wide, but that's also just the first design because he likes these more narrow beds for closed canopy successional systems. That's in the second session. So what does it actually look like? Not just a diagram, they've built these. You can probably buy one if you want to send your money to Switzerland. So this is what it looks like as it comes out the back of the tractor. And you can see that they've done a little bit of work to remove a bit of the sod already and then run this through. But that's getting below the plow pan, lifting the soil, and then tilthing so that you can put in these early succession cash crops. Because if you think I'm crazy putting garlic in on a monoculture next to my trees, you should see they work in much more complexity than what we're doing. What we're doing is, I enjoy it, but it's not as complex as it could get. So there it is. I think this is a really neat machine. Things like this are critical. But even if it was a business, could you justify buying one? It's probably not that expensive, but it's still a cost. And if you're only going to do it once, because you really, you're not going to run this next to your trees again. Once you do it, it's done. So if you have a lot of land that you're going to roll out on, sure, go ahead and invest. But maybe
can you rent one?
Probably not from Switzerland. So this is something that we're going to look at in the next agroforestry project. Is encouraging farmers who are interested to start talking to each other, because people could purchase specialized agroforestry equipment as cooperatives and then plan the usage so that you reduce the cost. Because everyone doesn't need to have one of these gathering rust on their farm after it's done. So that's quite understood. Tractors and appropriate technology. I kind of already touched on this first point here, ensuring unimpeded workflow. So if you are a farmer, think about agroforestry, don't cut the corners. Make your headlands wide. Make the margins as big as they need to be. All right, so use that normal thing. So please don't copy what we're doing. We're doing it because we have an idea of why. But I don't know if you can make out these fence posts here. And if you remember the alleys, these are being drilled with 7 plant families, so about 15 plant species, cover crop mixes into our dry soil, planted with a 3-meter wide planter. 4-meter wide planters are considerably larger than 3-meter wide planters. So when we brought in the 4-meter wide planter, which still fits within 12 meters perfectly fine, I had to have, and I did have a lot of faith in Mats Wickner, who did the sowing for us. But my heart definitely skipped a beat as he was driving, he was planting this alley. They're about 100-meter long runs, and he's going down, and then he hits the brakes right when he needs to, and he doesn't hit the fence, and then he backs up and he does everything. So, but you see the whole machine go a little bit like, you would never do that on a regular farm. But in a project, the information we generate is like just as important as everything else, because that's a little technicality. The spraying, that worked pretty well. So we did get to use the tractor once. Because of the drought, we wanted it more than once, but we did get to bring the tractor out and apply a biostimulant with a little bit of biofertilizer into the alleys and marges. And we also tested, we'll talk about that in the next session too. So we were able to do that. That works out nicely. And you can say that the field smelled a little bit like seaweed and fish when we were done, but it's okay, it's organic. So then the next picture is one that I took out the back of the tractor that's, before this, just demonstrating a little bit about appropriate technology. So we were harrowing the margins in the alleys to create the seed bed for Mats to come in and put these species in. But I was taking the picture out of the back because we would like to mechanize the work in the tree beds. And Ricard's going to like what I found last night at around 11:45 to put in this next presentation. I really start to wonder about the energy use if we were going to have a tractor pulling a machine to work a 75-centimeter bed. First of all, I don't really want to sit down that long. I'd rather walk next to something. And the other thing is, like, I don't need the tractor to move me. I need the tractor to move the implement. So we're going to look at how advances in especially electric motors, and we just this plethora of electric vehicles and electric driven machinery in the last decade or so, how that's being applied. So these are questions, but at the same time, if you have the irrigation delivered and set up on time, garlic in our context where we are in the Helsinki region can pay for the labor, the hand labor involved to doing these things. I don't want to do the hand labor, but I'm willing to do it when it adds up. Of course, it doesn't add up when the crop fails. Some of you have seen that. We have some repeat visitors to the field here, but Joskus Cow 9. So it's a development project. You're not allowed to start your project until it's been formally approved. So we couldn't extend the timeline. We couldn't bring the irrigation system and have it ready from day one. You have to actually go with the implementation timeline as a development project. So again, that's it's a kind of a mark against development projects, but over time it's going to work itself out. I'm not too concerned about it. And that the last bit, test purchasing decisions, is what I kind of talked about. How do you justify it? You have to know your numbers. You have to know what it is you're producing. Does it make sense? Is this thing going to move me towards my goals? And you can apply that to everything from buying a tool that does the weeding with you to even doing agroforestry in the first place. Okay. And as I said, I'll probably run out of time. I don't even know what time it is. It's 13:58. When was I supposed to end this session? Probably at 14:10. So I actually am just on time. So I ran out of time. I meant to talk about soil and sap analysis in this first hour, but I moved it to the next one. But I put this picture up here because a little food for thought as we take a break after the Q&A. Our soils test between about 5 and 6. So I think it's moved because we were actually a little bit in the high 4s and some. And then on average, they're about 5.3. So this is a standard. No agronomist worth their salt would just look at this and then look at a soil lab report and then tell you what to do. But to pretend that this chart doesn't influence a large part of how we think about soils would also be a bit of a fantasy. Okay, so this, when you follow that pink line, look at nitrogen, look at phosphorus, but to all of these here, So our main nutrients and the macronutrients, at this level of acidity, strongly acidic, we should have very low availability, simply because of how the soil pH is. Of course, you have to add in a few other bits of information, but we're going to see whether or not we saw this happen in our field. And then also notice what should be highly available: iron, manganese, boron, copper, and zinc. And unfortunately, our good friend Molly, because I'll never pronounce her name all the way, Molly Benyam over here. Yeah, just have David say it for us every time. Okay. You know, I'm not saying this chart's completely wrong, but it definitely raises some interesting aspects when we go to the next session and we look at when we started to test the plants. Because remember, we apply no lime to the soil. The only major input with that big asterisk was the compost. And we deliberately chose horse manure compost because it has very little of anything other than carbon in it. And it's a one-time input. And then I'll talk about it a little bit more in the next one. I just like to keep talking. I'm done for now. That's the first session. We have 10 to 15 minutes if there are enough questions for some.
There are questions in the chat,
Oh,
and
thank
I
goodness.
bet there are questions also in the room.
Okay, so Marianne, would you like to sort of supervise
Here is the
this?
session. Yes, let's see where the questions start. First of all, do we have questions here in this room? Please raise your hands. Otherwise, we have Robin asking, how do you harvest the crops in the tree lines and between the trees? Are you going to do it by hand or with a machine? You said it pretty much already, but...
Robin, I will answer that question very soon because I'm staring my logos in the face. I'm a poor project manager. So it makes it sound like we also didn't have any other help. I'll get to the answer in a minute here. Our project has been funded very graciously by last year, Jordfonden. That's an abbreviation as well from the Swedish. They were kind enough to continue to support our project even after an initial indecision from the Rural Development Fund. So we got started last year on private financing through Jordfonden and Novia. So without their belief in this project, we wouldn't be where we are today. And then our project was picked up again and looked at second time by Elu-Keskus, who decided to take and bundle some funds that they had left over from a previous session and say, if you can use this in a year, we'll fund you for a year. So Jordfonden continued helping us this year, but we also got 60% financing through the Center for Economic Development, Transport, and Environment. And I'm still like totally dazed that they decided to pick this project up because it is going out on a limb. And so they are taking a bit of a risk, as we all are, and we're all trying to learn together. So I want to thank everybody who's made this possible. So very quickly, by hand. We're harvesting stuff by hand. And we're going to talk about how and why in the next one, but short and simple is that with a community-supported agriculture model, you can decide how you want the harvest to take place. We're building on Ricard's apple orchard where people pay up front for a professional to manage the site, to manage the orchard. He tells them when the apple trees are ready for harvest, and then it's an event for them, their family and friends, year after year in many cases, to come to the farm, and sometimes from the very same tree to pick the fruit. So we're going to expand the products available to the existing customer base or other people who are interested, so then we cut out that labor. That's a context-specific adaptation. Obviously, everybody's not going to have the ability to have people come to their farm, but we're not farming for everybody. We also have to make this work for Ricard because his farm is where it is, and we have to leverage the benefits that he has. So the labor requirements is a big question mark that we'll talk about later.
There are many more questions, so you're going to have to stop answering now.
Yes.
There's another question here. How do you plan to deal with the wide spacing between the perennials in the time that they are still establishing and still quite small? I think you answered that too.
Okay.
You start from the beginning of your talk, but please recap.
Well, it's not very tight spacing. I'm not going to really, I'm not sure if I could zoom in. Wow, that's 150%. It's not that tight. So the fruit trees that form the canopy strata are 3 meters apart, and they're in groups of 3. So you have 1, to 3, usually sweet cherry, pear, or sweet cherry, plum, and then pear. And then 1.5 meters, so right between those two is a rhubarb plant. Not rhubarb, currant, red or white currant bush. They need a little bit less light than the fruit trees do. They still need a lot of light, but we have 14 meters between the tree lines. So as the sun moves around, there's going to be a lot of light penetration through the canopy. So you also have not just the fruit trees, we have the currants. And then the fruit trees are also then straddled on either side. Each fruit tree, 75 centimeters from the fruit tree, has a rhubarb crown. So you have a canopy and a low strata. I don't know where the camera is. There's canopy and then a low strata right next to each other. And then we move slightly up with the currant bush. And then between each group of 3 that uses this planting pattern, then we widen and we have a nice little gap. And that's about 6 meters between the last fruit tree, that pear, and the next sweet cherry. And we widen that gap in part to have a physical barrier because all of our canopy species are all in the rose family. So although they're different species, they share a lot of similar pests and problems. So just simply widening the space and leaving a gap also helps a bit with sunlight, and that helps with sterilization, keeping things kind of clean. And then what do we plug in there? We plug in black currants because black currants need a bit more sun than the red and white currants. So there actually isn't much space at all between those species. And then when you have a high density cover crop on one side and a high density garlic on the other side, there isn't much room left for anything else, although I slipped some stuff in that Ricard doesn't even know about. You'll see on Monday in the final report. Yes?
Yes.
I think he specified his question. Chris specified the question, I think, to... It was about the mulching.
Yeah, but
Okay.
all right, here.
Any questions from the room?
I meant weed suppression, mowing, mulching. Right, now I see it.
Okay,
That's
so
it.
one of the aspects of the project when we wrote the application was to see how we could take 2 divergent strands of agriculture and bring them together. So my experience as a small-scale market gardener, hand tools, high-density plantings, could we apply some of that knowledge to what remained unseen, to me anyway, from my experience, was this agroforestry? Can we bring that experience, the market garden experience, to successional agroforestry, you'll see the numbers later, 10, 13% of a field that produces wheat, integrate this successional model, and thereby stack in new enterprises that produce a lot more revenue per square meter, while then also extending so-called ecosystem services into the alleys and the arable crops. So right now we're using manual weed control and occultation. In the long run, it'll probably still be mechanical weed control, but mechanical that is power tool based in some sense, right? So either PTO on an existing tractor or some other kind of device, because it's a simple motion, but again, that cost of investment is really high. So the mulching, we'll also talk about, I'm going to leave that for the next session. So we're going to talk about the mulching later.
I think we had one question. Did we have a question here?
Just
and then we're going to break for coffee. So you answer the other questions.
Just the tree lines, are they different just because you want to test out which one works best to gather different data, or is it like based on some other?
Oh, yeah, great. That's a good question. So it's hard to see here, but if you go to the, here, let's go, this one's a bit better. So the field slopes to the northeast, so you're going higher in elevation. It's not a huge difference, but it's enough that tree line 1 is at the top of the slope, tree line 4 is at the bottom right now, but then we'll have a 5th one, which is going to be a riparian buffer with no compost. So we're trying to also integrate there. So in the middle, T2, 3, and T4 use almost identical planting pattern because they make up the bulk of the site. They have the most deep soil in general, and that's our main production zone. Up here, tree line 1, we have very shallow, poor soil running for large sections. So you could put apple trees with irrigation there, but you could also put grapes. So few people know about grapes in this room. You could try something new, put it at the top. Good cold air drainage when you're at the top of the landscape. We get full day sun here. Even here next to these tall trees in October, the sun peaks around here mid-morning, and then as you saw that October photo, there's just full sun pulling in all day long. So we have a really good potential to produce something there. Then tree line 5, which is great out here because it's not planted, but it's the furthest in development, is going to be a riparian, the objective is a riparian buffer that's going to be implemented more with the Ernst Goetz style with no outside inputs other than biology. So we're not going to put compost. We're going to be using a different method to do that. And that's also because it's literally right next to a perennial stream. And the stream leads to the pond where the irrigation water comes from. So I don't want horse manure. We already have enough deer manure to deal with. We don't need anything else. So yes, there is a differentiation based on location in the slope, soil profile, and then that of course allows us to expand a little bit in terms of what we're going to plant. So grapes up here, and then at the bottom we're going to be looking at black elderberry, which can produce 25 to 30 kilos of fresh berries per bush in our climate. I mean, it's a lot of berries. And black elderberries are still kind of rare in Finland, so again, Ricard's, oh yes, my. and then honeyberries. We're thinking about doing honeyberries there as well because they can handle some heavy soil. Yeah.
Right. We're going to break for coffee now. There are still questions unanswered in the chat, but they will remain so for a bit longer. I suggest everybody goes and gets a cup, and then you can, Joshua, I won't let you stand here. You have to go and chat to people so they can ask you all the things they didn't dare to ask you standing while you
we should mute it then. We should mute the...
Yeah. And then we will get back in. Let's see. We will go on 14:25 to hear about the future. And then the session ends with Michel Den Herder, who will talk to us about agroforestry for Finland. He's an expert on agroforestry in Europe and in colder climates on the whole width of agroforestry. Right.
And that presentation will be a little bit shorter so that we can hopefully get to lots of questions at the end of the day. All right, coffee.